I'm not sure I should say good afternoon at 12:45. Well, it's the afternoon anyway. Welcome to this plenary event 5, which is dedicated to space technology application in support to management of potentially hazardous events. First of all, I would like to apologize for the timing of this plenary, which is at lunchtime, and that is because today is a very special day where there are 3 plenaries packed into the schedule of the day. So this plenary will be followed by plenary event 6, right after this one. This plenary follows the UN IAF workshop that took place here in Glasgow last week on the 26th and 27th of September. The workshop, which takes place every year, organized jointly by the United Nations Office of Outer Space Affairs and the IAF, was this year dedicated to reviewing the use of space technology in support of the management of disaster situation. So the format of this plenary will be the following. First, I will ask Ambassador Ciro Arevalo, who is the current chairman of the UN Committee for the Peaceful Use of Outer Space, to present to us the conclusion and recommendation coming out of the workshop. Then I will ask each member of the panel to react and comment on those conclusions and recommendations based on its own experience in his country, and you will have noted, of course, that the countries represented here are emerging spacefaring nations. Let me introduce first the members of the panel. I will start with Professor Borofiche, who is the president of the National Space Research and Development Agency of Nigeria. Maybe you can wave your hand. Thank you, Professor Borofiche. Following an alphabetical order, I will introduce to you Gilberto Camara, who is the Director General of the Research Institute, Space Research Institute of Brazil, INPE. Gilberto Camara. Then Peter Martinez, who is the coordinator of the National Working Group on Space Science and Technology in South Africa. Peter. Then Professor Conrado Barato, who is the Executive Director of CONAE Argentina, the Commission for Space Activity in Argentina. Then David Williams, Director General of the British National Space Centre. Thank you, David. And finally, as I said earlier, Ambassador Ciro Arevalo, Chairman of UN COPIOS, who is from Colombia. I have to send you the apologies from Yvette Stevens from OCHA, who could not make it to this meeting here in Glasgow at the last minute, from Assedine Oussedik, who is the president of the Algerian Space Agency, who also could not make it to the Glasgow today, and for Dr. Suvit Vilbushrez from the GISDA organization in Thailand, Geographic Information and Space Technology Agency of Thailand. And he has, in this case, I must say, a very valuable excuse. He is launching TEOS, the first remote sensing satellite of Thailand, today. In fact, the launch was supposed to take this morning, but I have not have confirmation that it has taken place so far. So I will start now by asking Ambassador Ciro Arevalo to present to you the conclusion and recommendation from the UN IAF workshop. Ciro, you have the floor.
Thank you, Gerard. Well, it is an honor and a privilege for me to present to this plenary the results of the workshop on integrated space technology applications support to managed potentially hazardous events that were organized by the Office of Outer Space of the United Nations, as well as the International Astronautical Federation and the European Space Agency. The work took place just before the beginning of this Congress, the 28th and the 29th of September. The recommendations and questions, they are not only recommendations, but questions were reached by, in a final roundtable by a panel of high-level experts from all over the world, all over the globe. I have to say that all geographical regions were represented, but mostly from developing countries. The result of these 2 days deliberations and the presentation of more than 30 papers that were submitted there were the result also of the very interactive exercise with the participants, not only in the exchange of data, information, perception, systems, national perspective, but above all, an exchange of experience. But we have to remember that any single disaster is different. Any single disaster is unique, and we have to be prepared according to our experience. The conclusions were the result of these discussions, and I have to say that we try to resume, to synthesize all of them in 1, 2, and 3 thematic clusters. First, you are going to see major concepts that everyone agrees that they are the ones who are going to be presented here, but then 3 clusters, which are, first one is...
Could we have the slides, please?
The first one is going to deal with the communication, the relation between the disaster management community and the space community. The second one is going to deal with international cooperation, both in national, regional, and international perspective. And the third one is going to deal with capacity building. Well, finally, I would like to say that this was an incredible exercise. It's demonstrated that disasters are going to come more and more. There are scientific evidence of that. And I would like to thank here particularly the Office of Outer Space, Maslin Osman, who is just in front of me. She was kind enough to ask me to share the conclusions since I was the moderator. Thank you very much, Maslin. And also, of course, the International Astronautical Federation, who was one of the co-sponsors. Well, that is what I want to say. I just want to present the conclusions, major concepts we have in front of us. When considered in an integrated approach, this is a key concept. Space systems can be most effective tools for disaster prevention, monitoring, mitigation, relief, and rehabilitation operations. This is first major concept. Second, current satellite, image, and geospatial data services are accessibility to them on a timely basis are crucial for disaster management. Third, satellite communication provides the most reliable method of voice and data link during disaster operations. And then finally, relief operation and telemedicine through satellite communication can help to save many lives of people affected by a disaster. Then we have the first cluster, which is the relation between the space community and disaster management community. Integrated use of space tools and applications, including technological knowledge and expertise, are key areas to reinforce in any cooperation between the space community and the disaster management community. Then, 2 key questions to our colleagues here. Within the disaster management cycle, which are the key barriers? For instance, critical, timely data gathering. How can this be alleviated using space technology? Is the base relationship between the two communities. Then, what is the methodology within the space sector for communicating with the disaster management sector? We're up to the cluster number 2, international and regional cooperation, programs and initiatives. International cooperation was recognized as a structure that
Next slide, please. Next slide.
Next slide, yes.
Next.
Thank you. Have proven very useful.
Next.
Yes.
Okay.
There. Thank you, Gerard. However, is insufficient coordination to integrate national systems with international cooperation structures. There are relations, but this relation is not enough. Then, first question, what role can national, regional, and international mechanisms in the space sector, for instance, International Charter on Space and Major Disasters, GEOS, EU ISA GMS program, and UN Spider can play in the full disaster management cycle? Then the last question in that particular cluster, how can developing countries join and gain benefits from international and regional programs? Dissemination, big problem of data and experience. Both are required for disaster operation. We have to have a reflection on that, your opinion on how to disseminate information. Therefore, regional cooperation among developing countries and between these and the space communities are crucial to accumulate technical experience. Finally, cluster 3, national capabilities, capacity building and awareness raising. Key elements of capacity for disaster management. First, disaster information system, disaster risk vulnerability analysis and identification of critical areas, ability to predict disaster and early warning, and ability to perform timely and precise early warning. Of course, ability to monitor disaster. And to finish this cluster and the whole presentation, one particular and important question, do the space agencies include awareness raising, capacity building, and in-depth education in your overall planning? That's all. Thank you.
Thank you very much, Ciro. Thank you for this brief summary of the conclusion and recommendation coming from the UNIF workshop last week. Now I will ask each of the members of this panel to comment on, if not all, at least some elements of this conclusion, based on their own experience in their own country and some reflection that they might contribute to this debate. So I will start maybe with Professor Boforis from Nigeria, for the Nigeria Space Agency.
Well, thank you, Mr. Moderator. I think this session gives me the opportunity to share with this session my experience, our experience in Nigeria, in the area of space application, particularly in the area of disaster management. Nigeria, as you know, is an emerging space nation. The National Space Research and Development Agency was established in 1999 to implement programs enunciated in the National Policy for Space. And within the context of that policy, the thrust is to use space as a tool for socio-economic development and to enhance the quality of life of Nigerians, because at this stage we cannot afford the luxury of space exploration. So we focus on the area of space application. I will speak first on the issue of country experience. We launched the first satellite in 2003, which is a micro satellite, an Earth observation satellite deployed into the low Earth orbit with an optical payload with 32 meters resolution and 600 swath width. This has been in orbit for the past 5 years. And the data received from this satellite have been used in various situations to address problems of environment and particularly disaster mitigation within the country. For instance, in the northern part of the country, the major problem is desert encroachment. And we have deployed this the satellite data to look at the problem of desertification in the northern part of the country and to come up with a model as to how this encroachment can be stopped, because it is a major problem in terms of land use, land cover, land available for agriculture and other uses. In the southwestern part of the country, we have deployed the space data to look at the problem of deforestation, which is also a major part within the southwestern part of Nigeria, leading to biodiversity depletion. In the eastern part of the country, the major problem there is the deep gully erosion, destroying houses, farmland, roads, and we also have used this satellite data from Nigerian Sat1 to look at the problem of gully erosion and to come up with model as to how this problem can be solved. We've also looked at the area of flooding in the middle belt, creating a sort of vulnerability map for flooding, which can be used for mitigating activities against flooding in the middle belt of Nigeria. Now, these are some of the areas where locally we've been using the satellite data in the area of space application, particularly in the area of disaster mitigation. However, it must be recalled that the Nigerian Sat1 is a member of the DMC, that is Disaster Monitoring Constellation, which consists of four other satellites contributed by 4 other countries, one by China, one by Algeria, that is ALSAT-1, one by Turkey, which is TUPISAT-1, one by UK DMC, that is a BNC SC, and one by China. These 5 satellite works in a constellation, and jointly we are a member of the International Charter on Space and Major Disaster. And so each of us contributes about 5% of our data to disaster mitigation or management globally. So this is one of the ways by which Nigeria is contributing to the global effort in disaster management. Of course, we also embrace the idea of UN SPIDER, which is creating a platform for space-based information for disaster management and emergency response. On our part, we have offered that Nigeria will be a hub for the West African sub-region and to provide the necessary leadership in that sub-region in collaboration with other hubs in the African region. And I think these are the areas which we have deployed our services. We are members of the CEOs, members of the GEO, and we hope also to contribute to the global observation system in making data available to our other nations in the developing country.
Thank you very much, Professor Bovorowicz, and you will have noted that the next plenary taking place right after this one will be devoted to GEOs. So this shows that the connection between what our friends in Nigeria are doing and GEOs is very well established. Thank you very much. So maybe I will propose to change continent and ask Dr. Barato to share with us his experience with the CONAE, the Argentinian Space Agency, who is very active in this area, I should say.
Thank you. Maybe not everybody is aware, but Argentina is the country in the Latin American region which is the most exposed to emergency coming from natural disasters. We have a problem and we have a solution. When we look at the way the protection agency works, we found that they are very well prepared for the reaction and mitigation phases, but really when we think on space information, we have to give a very special attention to early warning. if we were able to have the protection agency involved in understanding and in making a taking real advantage of the space information for the early warning, certainly in many, many cases we will be in a situation where the consequences of this disaster coming from natural situation will be by far the consequence by far less relevant than what they are now. Our experience is that this can be done if there is a close relationship between the space sector and these protection agencies. One of the best ways to do it is through the preparation of what is called in the Charter, International Charter Project Managers. For this reason, we have organized in the Latin American region courses to prepare project managers for different countries. And these courses have been replied in different other places, in Asia, in the United States, etc. And really, when we look at what happened after those preparation of project managers, we can say that they are very effective. For example, there are very good examples in the case, for example, Peru, when they got the earthquake. The concept of having very good prepared project managers, having a clear idea what it means to use the information coming from space, helped them a lot again in the reaction and mitigation phases. For earthquake, unfortunately, I don't think that still we are in a position to make a very early warning, but in many other cases we are in a position to do it. So the point that we should focus is how to have those protection agencies working together with the space sector and really emphasizing the early warning aspects. In our opinion, one of the best ways is to try to have regional space agencies. That's why Argentina is really trying very hard with other very friend countries to have a kind of regional space agency, because we think that will be the best way to have everybody involved in trying to understand these problems and trying to really to have the space information tied to early warning. For that reason also we have in the capacity building side, we have a school over there which is called the Woolwich Institute, which is really emphasizing all the work on that institute, not a school, is emphasizing the use of space information for hazards and for particularly on early warning for hazards and for health situations. If I will have to make a final comment relating to this Congress and the United Nations organizations, actually what I will say is this. It's more relevant, and this is my opinion, it is more relevant to have forums like this Congress, and particularly to have the United Nations organization involved in having the protection agency of the different countries to really understand the relevance of the space information for early warning than to be so much involved in what they call the operative aspects. It's not that I'm saying that they are not have to be involved in the operative aspect. They are doing a lot of work and they are doing very, very well. But if I would have to put a priority, my priority would be please work on really on having those organizations to have their mind prepared to receive and to work with space information, and particularly to have their people prepared not only for the reaction mitigation phases, but particularly for the early warning phase. Thank you.
Thank you very much, Dr. Barato. Thank you, and I know that you speak from real experience, so the message that you just passed is important. I will now turn to Peter Martinez from South Africa, who will share his views and comments. Peter?
Thank you. Thank you, Dr. Brasher. Thank you for the invitation to participate on this panel. I think the UNIAF workshop that was held here last week provided an excellent opportunity for the exchange of experience between the different communities of practice, namely in disaster management and the space community. And certainly from the South African side, we appreciate the support by USA to allow South African space experts to take part in this workshop. I'd like to focus my remarks on the question that was posed in Dr. Arevalo's opening remarks, where he asked the question, within the disaster management cycle, which are the key barriers to the efficient use of space technology? And in our developing nation context, I'd like to identify a few of these. Although South Africa does not yet have a space agency, we are well on the way to establishing one. Our legislation is currently going through the constitutional processes to establish a space agency, but nevertheless, space applications for disaster management have been used extensively in South Africa and in the Southern African region for some time, and this is done through our Satellite Application Center, working closely with our National Disaster Management Center. And these two entities have worked very successfully to address disasters in a reactive, although at this stage not yet a proactive manner, I believe. And I'd like to reflect on some of the barriers that are preventing that at this stage. One of the challenges, of course, to us is to have the appropriate human capital to utilize space-derived geospatial data for disaster management. And one of the challenges that we're grappling with, and we haven't yet resolved, is whether to develop this capacity centralized at national level or whether to disseminate it as widely as possible to regional and local level, and at what are the appropriate levels of training that are relevant at the various layers or tiers of government. The other thing that is clear to us is then also in relation to this capacity building issue is that it should be as easy as possible to utilize the space data product. So this means using intuitive, easy-to-use interfaces, perhaps platforms like Google Earth or Whirlwind, where the space-derived data can be easily accessed through these intuitive, easy-to-use platforms. The other challenge that we have, of course, is the issue of converting very successful pilot or demonstration programs into operational programs, which usually run into problems of a fiscal nature. So those are some of the challenges that I'd like to point to. Thank you.
Thank you, Peter. Thank you, and it's very interesting to hear that South Africa is in the process of setting up a space agency, and we look forward to speaking with and interacting with the space agency of South Africa in the next months or maybe early next year. Now let me turn to Gilberto Camara from Brazil, who will share his long experience with us.
Thank you, Gerard. Could I have slides, please? Yes. I will address some of the issues related to the Cluster 1, the barriers. And we think that the link from Earth observations to natural disasters depends on the availability of three key components. The first one is free data accessible. The second is free software for data integration. And the third is capacity building. I will go a little bit on these issues, which I think will try to address what is the needs for using space information to support natural disasters. Would you please have the next slide, please? Okay, as you probably know, Brazil is making a strong effort together with our partner China to deliver CBIS data as a global satellite to cover the tropical area, most of the Earth's land mass between +30 and -30. And we're going to talk about this in the next plenary, just to tell you that this is, of course, part of a global vision, which we hope it's not only Brazil and China, but all other nations will provide their Earth observation data free of charge to everyone on Earth. Next one. Now, the other issue when you talk about capacity building is that land imaging is not enough. And the point being that we need good topographic maps. And there comes a challenge because, as some of you certainly know, the United States and Germany have the Shuttle Radar Topography mission, which has covered the Earth, and they have a DTM, a digital terrain model, of 30 to 30 meters, However, for security reasons, they only provide 90 to 90 meters, which is not enough for the disaster handling in most cases. Now, what Brazil is doing, we have done this for Brazil and will do this for Africa, is to interpolate, using geostatistics, the SRTM-based elevation data in 30 to 30 meters and make it available for Africa up to the end of next year. Of course, when we do that, the Americans will suddenly release the 30 to 30 meter data, which is of course better than interpolated, and everyone would be happy. It's a good way to take the data out of the vaults where it has been left. Next one. The other point which we think is very important is software for data integration. I'm not going to go into details. This is a free software Brazil is developing and using for disaster management, which then we hope that together with other tools of free software for deforestation, for land imaging, for spatial data handling, are to be made available on the internet. Brazil has, in INPE, has a very strong information technology capability. We're fully committed to free software. So this is our next step, is the free software for disaster management, which integrates meteorological data, climatological data, social data, terrain data, land imaging data, and provides analysis, early warning, but also forecasting of disaster points. And again, this is a contribution that Brazil will be putting together to the whole Earth observation and space community. Next one, please. Okay. So, that said, we think that in disaster management, the data barriers can be lowered by us, the space agencies. But the software barriers also can be lowered by us. We can make an effort to provide data integration tools, which are then distributed to everyone, which integrate social, meteorological, climatological, terrain, and land imaging data. And Brazil hopes by that to make a contribution, and that we hope others will follow in this model of free data and free software. Thank you very much.
Thank you, Gilberto. I must say I particularly like your description of the strategy to make the 30 by 30 meter 30M data available, and we'll be observing with a lot of interest whether your prediction actually is confirmed over the availability of the real for 30 by 30 meter data. Thank you very much again. And I will now turn to David Williams, the Director General of the British National Space Centre. David, over the last year or so, chaired the board of the Charter, the International Charter of Space and Major Disasters, and I thought it might be useful to have also his view on the use of space system and space technology in support of disaster management support. David?
Well, thank you, Chairman. I think I'll try and focus on three areas where I think the space agencies, what we might call the developed world, have taken steps to help in the support of disaster management. And the first one is the national example in the UK, which my Nigerian colleague has already referred to, the disaster management constellation. That's an interesting partnership, first of all, between UK government, BNSC and industry, Surrey Satellites, where we developed a satellite specifically for disaster monitoring, medium resolution, wide area swath system, and put that up and made it work. And consequent to that, then, we work with other countries in the world, and as we've said, Algeria, Nigeria, Turkey, China and Spain, all are satellites in that constellation, which is managed from the UK and which works together in times of disaster to make all the data available. And with 6 satellites, you get very good coverage on a time basis. So I think that's an example of how at the national level we've worked to develop things. At an international level, there are 2 areas that I'll mention. One from my previous life, which is the Meteorological Office system, which is run under the auspices of the World Meteorological Organization. And it's clear there that the series of satellites that give data for weather around the world are very important in forecasting and predicting a wide range of disasters and also helping to respond to them. And through the WMO, all those data are made available in times of disaster and also made available to countries that can't afford necessarily to have a system if they're susceptible to hurricane or typhoon or cyclonic weather, severe weather systems. So there is a system in place there which enables all the weather satellite data to be made available. And the third one, which you mentioned that we chaired for the 6 months ending earlier this year, is the International Charter on Natural Disasters, which basically brings together those agencies with satellites of the medium to high resolution that need to be programmed to get data over a specific area. You know, they cannot, if you like, image the world entirely every time, all the time they're working because of power constraints. They need to be programmed and managed. And under the Charter, the agencies and countries have got together and agreed that when there is a disaster, the country affected can call into play the Charter, activate the Charter, and then through a well-organised mechanism, the satellites are programmed to target over the area that the disaster's occurred to provide imagery and data that can be of help in mitigation and downstream help. So I think that's a working example, and it's there 365 days a year, 24 hours a day, and each member takes it in turns to operate the desk that receives the disaster call, and we work with the foreign offices in each country. I think one of the areas, and that's a very good working example of how existing assets are being used and deployed. The one area that I think we're all working on as well, and perhaps we'll hear more of it in the next session, is the dissemination mechanisms for data. And there we have, at the European level, both ESA and EUMETSAT, the two agencies, developing systems to disseminate data primarily into Africa, but broader. And through GEO, they've developed a GeoNetcast, which manages to do that internationally for the whole globe. Because one of the problems that you always face is it's very good having the data, it's very good shipping it to the country, but you actually have to get it down to the people in the field who are doing the work and actually managing the disaster on a minute-by-minute, day-by-day basis, so they can use the information to help in the local planning as well as the sort of international planning of movement of supplies and backup materials. So I think the picture I'm trying to paint is there's a lot going on there, and underpinning that there's a lot of training going on. And I think we do work well together as a community with countries and with countries that are susceptible to disasters, certainly disasters of a natural kind through cyclones, hurricanes, etc.
Thank you, David. Thank you for this brief description of the British involvement and experience in this area. I think now what we will do now for the next 15 minutes is ask the floor to address questions to the members of the panel. But before I do so, maybe I will ask Maslin, the director of the UN Office for Associated Affairs, that if she wants to say a few words. So I think there is a micro somewhere in the room. Okay, Maslin.
Thank you very much, Gerard. And the United Nations would like to thank IAF for supporting us in this very, very important topic of disaster management. It's left for me now to inform everybody here that the General Assembly has established the program. It was referred to already by Nigerian in the slide, a program called SPIDER, which is the space-based information for disaster management and emergency response. And the aim of this program is to provide universal access to all types of space-based information and services relevant to the disaster management community. And this we do by being a gateway to space information. We serve as a bridge to connect the disaster management and space communities, and we facilitate capacity building and hopefully strengthen institutions as well. The program has already established an office in Bonn, Germany. We'll have an office in Beijing soon, and a liaison office in Geneva. Nigeria also mentioned their aim of becoming a regional support office, and we will have a network of these support offices. Apart from that, there will be national support offices, whom we hope, together with us, will carry out activities that include capacity building. Everybody has mentioned capacity building here, awareness raising, and compiling information. And I'm so happy that to hear about Brazil's efforts in this. We will also provide technical advisory services to member states that request for them, including management planning and policy formulation. So we are hoping to work with all these member states and, of course, NGOs as well in the future for disaster management. Thank you, Gerard.
Thank you very much, Maslin. And as you can see from this very brief description of the objective of the SPIDER program, many of the questions addressed in Ciro Zarabello's conclusion of the workshop will be handled, will be taken care of in the context of the SPIDER program. So now I will ask if there are questions from the floor that I could address to the members of the panel. So who wants to take the first question? Yes. Can you introduce yourself? Yes.
Yes, thank you, Chairman. My name is Wen Jianzhang. I'm the director of the Observing and Information Systems of World Meteorological Organization. I'm really, appreciate the keynote speakers. They have, especially for the organizer of the committee, have a special session for the space technologies supporting the management of natural disasters. That's a great concern for also not only for the society but also for major of the international organizations such as WMO. I fully agree with Dr. David Williams, who speak several times about the weather satellites. We may understand that more than 70% of the natural disasters are closely related to the meteorological and climate disasters. My question is that we have a bigger slogan, from imagination to reality. I would like to ask the keynote speakers, what's your imagination for the next 10 years, especially something related to the capacity building? For example, we have not enough capability at the moment to observe some of the major disasters, for example, drought, for example, hurricane. So what's your imagination, especially for the new capabilities from satellite observations for the next 10, even 20 years? Thank you, Chairman.
Thank you, Dr. Dang, for this question. It's very much in line, your question is very much in line with the theme of this Congress, which is from imagination to reality. So who wants to answer this question? What will be our capability for observation in the next 10 years, or maybe even the next 20 years, if you...
David? Well, I'll have first go. I think the first answer is I think that's the next session, where we're going to talk about the GEOS, because that is about the global Earth observation system of systems that will bring together capabilities.
Yes.
But I think that where we are at the moment with the weather system, we're very good on the geostationary. I think the coverage there is good. The low Earth orbit support for that is also in place and working and just needs to be maintained. Perhaps the gap where we've got a gap in terms of the future is satellites that can give high resolution data. Maybe it can help in the mitigation, but also can help in the preparation. If you take something like the tsunami problem, one of the issues there is where will a tsunami actually create a wave at the shore, and where will it just peter out? And so you actually need continental oceanic basin shore mapping, say whether the wave would translate into something that would just be harmless, which it does on many parts of the coastline, or whether it would turn into a major wave. And the reason that's important is because even in things like surfing, some coastlines are more suitable than others, and that's because of the shape of the coastline. So systems that can help in the preparation of defining areas that are susceptible to the disasters, so that if something happens, you can focus your attention immediately on those areas that will be a problem, rather than think about where the problem will be. You could translate that to flooding as well.
And if I may, thank you, David, if I may, this question was also addressed this morning during the plenary session, which was a plenary dedicated to GMES and Copernicus. We had a question also very much along this line. And I remember somebody from the floor asked whether the satellite system would be in the future capable of observing more closely and getting accurate, useful data on the biological, the biophysical parameters, which also play a role in climate change. Of course, the topic of the plenary was climate change. So this, to some extent, the same question was addressed this morning, and I could say that there is a lot of ideas as to collect new sets of data, which will help both in the mitigation of disasters, in the earlier warning phase of disaster, and of course in a rebuilding phase after a disaster has struck. Any other members of the panel who would like to? Yeah, Gilberto?
Let me just say rapidly that what we have now is a mismatch between the funds, the public funds that have been placed for setting satellites, Earth observation satellites, and the public funds who have been set aside for developing applications. In the last 10 years, there has been in developed nations an assumption that the private sector would provide by itself the services that one needs in applications such as disaster management and other applications. And what we have seen is a complete failure of that model. So I think that now there comes a time when space agencies are faced with a situation that what is being getting out of their satellites is very little for the money that has been put up there. And that we need to correct for the mismatch between money which is being put to satellites up there and money which is being put in ground systems and data distribution and usage. And the fact that Brazil can do a lot of things whilst Europe is sitting on their feet currently is a major indication there is a lot to be changed on the policies of the European nations and of the United States.
Thank you, Gilberto. What you just said reminds me of something which is in process right now, and that is that the European Space Agency is proposing to its member states for the ministerial council meeting next month a new program which is called Integrated Application Program. And this program goes, if it is approved, and I'm pretty sure it will be approved, goes very much along the lines of what Gilberto is suggesting. More attention should be paid to developing the applications and testing the applications. Any more reaction from the panel on this particular question of the future capability of space systems, both in terms of data collection and in terms of application? If not, then I will turn to the next question from the audience. Do we have another question? Yes, Sergio Camacho, the former director of the UN Office of Outer Space. Sergio.
Thank you very much. It's actually a follow-up to the question and the answers, particularly what Gilberto just said right now. I see that one of the missing parts is talking about disaster is a lot more emphasis in the prevention part, and that is related to the use of the data that we have, the data that will be coming, in order that they are put into systems that alert what is likely to happen. We have many case histories already of flooding in the same place. It happens year after year, and we see sometimes very dire consequences from that. What is necessary in order to get the user to actually reach out for all that data? What are the efforts? I see that there is a gap there between the availability of the data that we have, which is a tremendous amount, and the use that it's being put to. What would be some of the steps to take?
Yeah, thank you, Sergio, for your question. I think you're addressing a very key issue, which was, I believe, in one of the conclusions, one of the clusters that Ciro presented to us earlier during this plenary. Who would like to react to this question? Dr. Barato, you have a mic.
Yeah. Just in the short speech that I delivered, I just talk saying that, in our opinion, the main aspect that should be addressed was related to what I talk about early warning, but we are talking about exactly the same. And this is tied to what Gilberto said before. We have information, and something I said before also, and I said civil protection people are mostly tied to reaction and to mitigation, but they are not prepared for early warning. They are not mentally prepared for early warning. And the only way to do that, in my opinion, is that on the capacity building side, we have to make a huge effort, having school, very well prepared people working on models such that they can deliver products to those agencies in such a way that they can realize that something is coming. Once we are able to do that, in a very few cases, with successful cases, they will really learn how important is it, and they will come along and they will start to work together with those people who are doing those advanced research and advanced modeling. I don't see any other way to do it. And I insist, we are doing a lot of very good work, but if we look, for example, at the charter itself, in the way it is today, the charter is a reaction. There is a situation, there is a reaction. However, in those places where the hazard happens, in many, many situations, it could have been alert before, just using the data that are already available, those historical data that are already available. So, in the future, and this is coming back to one of the questions that was done before, I'm convinced that not only the historical data, but also with the advanced SAR satellite that we are developing now, times will arrive where we will be able also to work in some of the hazards which are the more difficult today to give alert, which are, for example, the earthquakes. So really I'm convinced that is the way to do it.
Thank you very much, Dr. Barato. I think Professor Bovovich.
Yes, thank you, Mr. Moderator. I think the problem is a very serious one when we look at the developing countries, in that the institutional framework for addressing disaster management is not there. In most cases, what you have is emergency relief organizations that are probably not aware of the relevance of space-based information in both mitigation and the early warning process. So there's, in fact, in some developing countries, the space communities are not coordinated. They are not the meteorological agencies are not talking to the space agencies. The two communities are not talking to the emergency relief organization. So there's a need for a coordination that also raises the level of awareness of agencies responsible for disaster management to be able to utilize those data that are available for mitigation and preparedness.
Thank you, Professor Borovic. I think we have another question. Professor Rao. Yes.
Thank you. From the imagination to reality, there are two things which I think are missing. One is that, of course, many of the other things have been already talked about. I won't repeat. We do know that because of the climate change, there's a good evidence that the violent events, the frequency of that has increased. For example, you have sudden amount of rain, something like a few inches of rain coming in one day, and this type of events. And the basic problem is, one, prediction, modeling, and of course now some amount of work is being done on the analysis of the risk. And third thing is taking all the way to the last mile, the information going to the last mile so that people can be saved. That I think we should concentrate. The second thing is that one disaster, while today we have a fairly good handle on almost all the natural disasters, starting from the creeping disaster of drought to the violent disasters, one disaster is still a problem. That is earthquakes. As you are aware, there are many collateral evidences today. For example, we can look at the ionospheric disturbances. We can use it either the top side ionosonde or the bottom side ionosonde, or we can use the very long wave frequency transmissions, and we can look at the temperature of the Earth. But none of them are able to really make a prediction at exactly what place, what is the epicenter, what is the magnitude, and what is the time. I think we'll have to concentrate on this, where maybe it is the right thing from imagination to reality. Maybe we hope in the next few years, because the largest number of people dying is in the earthquakes. And I think we have to really concentrate. Things are gelling. There are many evidences, but none of them are up to the mark. But I think that maybe in the next few years, some concentration will help.
Thank you very much, Professor Rao. In fact, during the workshop, we had two presentations from our colleagues from Russia who gave us an update on where we are in terms of research with respect to earthquake. What are the indicators, if any, of forthcoming earthquake? And it was interesting to have an update, but it is very much still at the research and experimental stage. On this particular area of the earthquake, or also on the first topic addressed by Professor Rao, who would like to react and comment from the panel? Any earthquake research taking place in your country? From space, this is a tough one. This is a tough one.
Very tough.
I think no. I don't see a lot of enthusiasm to concentrate on earthquake research right now. But I think we have another question from the floor. Alice?
Yes.
Alice, who is in charge of the space application program in the United Nations.
Yes, thank you. We have many technical people here, and we heard a lot of concerns and effort being put in things related to data and imagery. Of course, we need those. However, in my past few years' practice, and I find out that, as Dr. Barlofis just mentioned, that there's lack of coordination. We have good technical people that you produced good analysis, very easy to use, and when the real disaster happened, where is the coordination? How can we deliver our product for the real use? So my question to the panels here are, we know that there's a lack of coordination, and we know that somebody has to take initiative to begin the coordination. And ourselves, of course, we cannot expect others to take the action. Among us, my question to you is, what kind of effort you think that we can do, or you can do, or we can do together to take an initiative to start the coordination looping? Thank you.
Thank you, Alice, for your question. So we are speaking more about the coordination of efforts taking place, I suspect, both at the national and maybe regional level. I know that there is some activity taking place, at least in South America. Huh? Yeah, Dr. Barato?
Well, I would like to take a point of what the lady says, is that, you know, if I would look at our experience in Argentina, I wouldn't say they have any problem at any level in the country to say, okay, we have to coordinate, and the people are doing a very, very huge effort on that. There is a point which we have to realize, and this is a language problem. As I said before, the civilian protection people are not used to the kind of information that those technicians, as you said, are able to supply. The effort before to, I mean, we can do any kind of effort, but if we don't have their mentality changed, that will be a problem. That's why I said before, we have to work very hard on the formation, the capacity building, to have those operative people to understand the language of the technicians on the side of the space information and vice versa. That is my opinion, is the world that we have. It's mostly a language and understanding problem than a coordination problem. Because the coordination, in some cases, it may be difficult, in some cases, it may be easier. But that is a key problem. And on regional level, I keep saying what I said before. If we have to work towards a space regional agency, because if we have a kind of space regional agency, also we will have a kind of regional civil protection situation agency, and they can work together. Maybe there will be symbiosis there. That's my opinion.
Thank you, Dr. Barato. I think, Gilberto, you wanted to say a word on this?
I just want to say that if we compare, I think on Earth observation and disaster management, we are now on the equivalent to the early 70s phase in meteorology, when the country started having their numerical weather prediction system. The numerical weather prediction changed our lives, our daily lives. Now, it is conceivable that the public, the governments, would fund disaster management centers who do disaster forecasts in a very similar way that now we do the climate and the weather forecast that you see every day on the BBC. So it's just a question of directing the focus in a similar way that has been done on the meteorological and climatological community, establishing a numerical disaster management center which will use all available data and really do numerical modeling of what will happen in the case of natural disasters. And I think that is the stage we are now. In 10 years, we'll be in a similar stage as we are on the numerical weather forecasting today.
Yeah. Thank you, Gilberto. I think that means there is a lot of work to be done, because some of the disasters we are talking about are very, very complex situations. I think there was a question in the back. I think José?
Yes. José Achache, Geo-Director. It's not a question, it's just an answer to the previous subject. I didn't want to leave it unanswered. Earthquakes. Just to challenge your imagination, we presumably will be doing seismology from space in 20 years from now using GPS. We're already able to look at seismic waves, looking at GPS, analyzing the GPS signal and essentially oscillations which are propagating in the ionosphere. So I will not let it unanswered that space doesn't have any response to earthquakes. It does. It will be the way of studying earthquakes and earthquake propagation in the future.
Thank you, José. You see, José Achache is a geophysicist, so he had to plus he has done a lot of work in this area, so it's a very good contribution to this debate. And you're quite right. It was not satisfactory not to have an answer to this question. I think we will take a last question because time is running out. And so last question, and then I will have to ask the panel if they have the final word.
Air Taylor here. Brief comment to the quake discussion for earthquakes. There's also a satellite on orbit today called QuakeSat. And quakefinder.com, you can track and correlate ultra-low frequency emissions correlated to earthquake events that may be used to predict them in the future.
Okay, thank you very much for this contribution. Still, it only means we are still in the research phase in this area. So I would like to ask the panel now if there is any final additional word that they want to contribute to our discussion. If not, then I will ask the audience to thank the panel, the speakers, for their participation. And now it's my turn to thank the audience for your attention and for the participation and the questions that you have raised. Thank you very much.